Okay, guys, so this is number 6, problem number 6 on your probability study guide, the one that talks about the houses and the garages. Okay, so basically, all you need to know is this basic stuff that I wrote down, right? I didn't copy it word for word, just like in my other example. So we have a total of 50 houses, and I'm going to go ahead and box that because I know that this is my grand total of houses, and I'm going to end up using that number. Then I have 20 houses who have 2-car garages, and I also have 10 houses who have 1-car garages, and there are a total of 20 houses that do not have a garage. Okay, so the question here is, if 2 houses were chosen at random, what is the probability that both of the houses would have a garage? So first, we need to determine how many of these have a garage. So these 20 have 2-car garage. I'm just gonna say G's. Okay, then these 10 have a 1-car garage. And then we have another 20 that have no garage. Okay, so it says a garage. We're looking for one of the probability of both houses having a garage. It doesn't say what kind. So how many have garages? Has a garage, has a garage. 30. Okay, so the first thing that we're gonna do is the probability of this being picked as a house that has a garage is going to be 30 out of the grand total, which is 50. And actually, let me rewrite this because I don't like that this pen is kind of light. Let me see if this black one is nicer. If I can open it. And I cannot. Okay. 30 over 50. This is the total of houses that have a garage and total of houses. Now, this is the probability of picking one. Okay? So, now we need the probability of picking another one that has a garage. So, if I already picked this one house, I cannot pick it again. So, that means that I am going to be subtracting. So, if I picked one and it had a garage, how many are left that have garages? 30 minus 1, which is 29. Now, if I had already picked one of these 50, my grand total will not be 50. It would be 50 minus 1, which is 49. Okay, so what is it that we have to do with these? Luckily, we do not have to add them, right? Because this would be a nightmare right here. We're going to multiply the probabilities so that we know what the probability of choosing one that has a garage is, and then choosing another one that has a garage. So if we do our multiplication, and actually I didn't write mine down, so I'm going to have to do this quickly on the side. Well, it's actually not even that bad because I can reduce. 3 over 5 times 29 over 49. How did I get this? All I did was I canceled these zeros to reduce. So I can do 29 times 3 and get my answer, and 49 times 5. And I should get 87 over 245. And if I were to divide that on my calculator, I get 0.355, which then becomes 35.5%. Okay, so we also had a question on dependent and independent variables. Okay, so I don't really think that we can do a whole video on independent and dependent variables, but this is a perfect example. So this number was dependent on whether or not we got or picked a house that had a garage. the initial probability was 30 over 50. Assuming that we picked a house that had a garage, then this number depended on that. Why? Because we had to subtract 1. We had to subtract 1. Okay, the house was not replaced with another house, right? We're not just going to pick up a house and put another one there because the one that we picked had a garage. So now we have 49 to choose from, and 29 had a garage. So that is why this number was dependent on the result of this one. Okay, an example of independent would be like when we talk about flipping a coin. Okay, what is the chance of getting heads or tails? It's half. Now what's the chance of flipping it again and getting heads or tails? It's half. It's never going to change. Just because the coin landed in heads the first time, let's say, the coin's not going to say, oh, I landed in heads, so now let me be tails next time. It doesn't work like that. It's always going to be 50-50. Okay, so this is an independent event. No matter what happened before, it's gonna stay the same. And in turn, this is dependent. Because these numbers depended on this. Whether or not I got one that was a house with a garage, and whether or not I was replacing the house, correct? So the numbers depended on this one. All right, hope this explained independent, dependent, and I hope that if you guys were having issues with this problem, that this helped you with the process. Have a good night.